Stop.
Sir, just sir, checking that you can streaming.
Just 2 minutes, sir. I just lost my internet connection. When I rejoined, I'm unable to. I'll just. Otherwise, I have to create one more link, sir. YouTube link. Because the previous link I'm unable to. Okay, sir. I'll just create one more link. Sir, we can start, sir.
Sir, we can start, sir. Good afternoon, all. We expect the same cooperation as well.
Good afternoon. Do you hear any noise from outside? So I shall not call it.
No, sir. No.
Fine. So I hope you had your lunch and I believe you won't sleep because with online participants are very relaxed. So don't sleep, take some assignments. We all will enjoy the session. And I hope you remember the things we have covered in first session. We were making program for XOR. In XOR, we have two inputs, one output. We have interlock in this program. When we press single button, single switch, output should be on. But when we press both the switches at the same time, output should be on.
Sir?
And we have to check
Yes, sir.
when
Just rechecking,
no one
sir.
switch is pressed.
Because in that link, I'm unable to get, sir. I will
Then
post
also
the
output
link,
should
sir.
be on. So what happens? Some people pay NC, NC, and output. So if your output is
Yes, sir.
directly
I have posted in the
connected
WhatsApp, sir.
through NC, supply will reach you. So in your lateral, only
Okay, sir.
NC should not be there to connect your output. Or
Okay,
else
sir.
your output will get on without pressing switch. So direct NC should not be there. Okay. So now you have press pen on your what I want, you people have done very good in first session. Many people have sent photo of solution program, and most of you were correct. So what I want, you try one example I give you now. After that, I shall give you the proof. Let me see whether you are able to make this program or not. In this new example, go on comfortable. Some people are saying they have issue in YouTube live session.
Sir, it is updated, sir. You are sharing the link to
Updated now.
yeah, updated.
Okay, so you programmers try to make one example. I give you the condition. Two inputs, I0, I1. Two inputs, and three outputs. Two inputs, three outputs. So inputs we shall have I0, I1. Outputs we shall have, let us give name, blue lamp,
Excuse me,
blue
sir.
lamp, and red. Yes.
Sir, your volume is too low.
Is it okay now?
Still, it's low, sir.
No. So you need to- you need it is a what to do then?
No, sir, it's bandwidth issue.
Okay, so we have two inputs, I0, I1. Three outputs, blue lamp, green lamp, and red lamp. So slowly we shall go for the examples, and don't worry, during session I think tomorrow or day after tomorrow, you will be able to make program for any PLC project with digital input. And lastly, last day you will be able to make program for analog and digital project program. So we shall go. So I0, I1, blue, green, green. Conditions. Condition is when you press I0, green lamp should get on. When you press I1, only I1, blue and green, both should get on. And when you press both switches, I0 and I1, red should get on. Got the condition? These are the conditions. When you press I0, green should be on. When you press I1, blue and green, both lamp should get on. When you press both switches simultaneously, red should be on. You have 3 minutes. Try to make this program. Send in group. I shall check, and then I shall come back to the quick or the easiest step. Please do that. try? Send it. So two switches, I0, I1. Two switches, I0, I1. Three outputs. Ah, Vivek, very good. You have tried well. You are trying very nice. Three outputs, blue, green, red. When we press I0, only green should get on. When we press I1, blue and green both should get on. When we press both switches, only red should get on. But you see, Vivek, you have taken four coils. How many outputs do we have? Three outputs. It means you should take three coils only, output coils. So here you have made mistake. Another thing is when you press both switches, only red should get on. In your program, all will get on. So that is the issue. Try again. Another guy, another people. Mm, Anmol, not yet, not yet. You are trying well. This is Sudeep. Sudeep, you are correct actually. Let me check once more. Yours is correct, Sudeep. Correct. Very good. No, no, no. Sudeep is correct. See, Rajiv, you cannot take outputs in series. See, I don't know who is faculty, who is student, so please don't mind if I call you by your name. Yeah, Kanha, not correct. Sudeep, that is correct. Yeah, I1, that is I1. I understood. Very good. Well tried. See, people are having problem with audio. See, I can't help you in that. Kindly ask your question in WhatsApp group. Kindly ask your question in WhatsApp group because it will be difficult for me to go for YouTube chat also. Kushuma, you have taken four coils, you see. You have to take three coils. Priyanka, you have corrected all only. You people are trying well. Kushi, you have taken four coils. You have to take three coils. Ganesh, if you press all
Yes, sir.
both switches, is it okay?
Which books? Actually, I0 green and if I1,
No, no.
okay.
If you press both switches, what will happen? All outputs will get on. Check. Correct, no? In your program.
Okay, sorry, fine, fine.
Got me. So when you press both switches, only red should get on.
Yeah, okay, sorry.
No problem. You're trying well. I think some people who joined through YouTube they could not understand the question because audio was not good. YouTube, people who have been attending through YouTube, is it clear now my audio? See, I told some technical issue will come. There, we can't do anything for that. Is YouTube audio okay now? I shall explain again, no problem.
Sir, is that the condition like we push the push button and these three LEDs should glow, or we can use NC where directly it can glow? I mean the load.
Correct. Okay, let us do one thing.
Yeah.
Let us have discussion on screen altogether.
Okay.
Let's, there is one correct solution, but his name is not here. He's or her name is not correct. Okay, fine. See, Gmeet link cannot be shared because I think it is already full. Gmeet, Google Meet. Some people ask for that. Okay, now I come to the screen. I hope I'm audible to YouTube people also, YouTube participants. So I shall go for some tricks. Coordinators, you please keep checking WhatsApp group in between so that we can solve the issues. I shall concentrate on it. We'll go to screen. Let us come back to XOR. Let us come back to XOR. I shall explain that through XOR. Vivek, it is correct. I shall explain the things using XOR, and then you have to try the same for this example. It is very important because after this you will be able to make program, any program. When we get program where we have simple conditions, just on and off, we don't have complication of delay, we don't have complication of count, we don't have complication of analog. It's simple. See, still audio is not clear. What can I do for that? In Google Meet it is clear, right? In YouTube it is not clear.
YouTube is like some devices running, like that type of noise is coming.
Is it so? Then I shall switch off my fan.
Maybe we'll check that also. Some device running type, sometimes like boot up time also some sound used to come, no? Like that. We are getting noise.
Once you check YouTube now, once you check
Yeah, sure,
YouTube,
sure. I'm checking.
uh, I have switched off fan, so I hope it would be clear now. And I told you in first session only such technical issues will come. Keep patience. We have 5 days. We will give you enough time. Now it is clear. Very good, very good. So it was my fault. Sorry for that. Now I shall go to screen. I shall go to screen. I shall start from XOR. So when we get some examples where we have just on and off condition, no complication of delay, count, analog, pulse, simple on and off. Let it be any number of inputs, outputs. Yeah, I shall repeat. Listen now. Uh, oh, what was that? Let it be any number of inputs, outputs. When you have simple condition on and off, follow few steps. So do not write down, just try to understand the steps. Then I shall follow those steps on XOR, and then you can follow that on next examples. So the steps I'm telling you. What I do, first, make a truth table. So when we get example, we should make a truth table. And this is for simple examples. So first thing is we should make a truth table. And you can see already I have made truth table for XOR, correct? Truth table has been made. So first, make a truth table. Second thing, go to the first output and take a coil for it. Listen carefully. Make a truth table, go to the first output. Here you see we have one output, but in another example I gave you three outputs. So don't be worried about all outputs. Do one by one. So first you go to first output, correct? Don't think about all outputs. Go to the first output and take a coil for it. Yet you have made your program, you have started your program from NONC. But for few examples, I suggest you start making program from coil. It will help you actually. And this is for practice one. So make a truth table, go to the first output, take a coil for it. Okay, first we shall take coil. Then check the true conditions of that output. So if you have come to Q0, you have taken coil for Q0, then you go to truth table and check true condition of this Q0. Means where is it on? So here you can see it is on here, it is on here. So go to the first output, take a coil for it, check the true conditions of the output, add the status of all inputs you have used. So when your output is true on, what is the status of inputs? You can see I0 is 1, I1 is 0. So input status we have 1, 0. Simply for input 1, you should take an O contact. For input 0, you should take NC contact. That is it. I shall repeat it once more and then we'll apply the same for XOR. Listen carefully. Make a truth table. Go to the first output, take a coil. Check the true condition of that output and add the status of all inputs you have used, all. For input 1, you have to take NO. For input 0, you have to take NC. Simple. Last thing. Do not make program for 0 of output. Do not make program for 0 of output. Now, look at the screen. I shall implement the steps on this program. And don't write down, do not note down. Just look at the screen, please. So, someone on audio, answer me. Very first, what we have to do? Someone reply.
We have to
We have to make the truth table.
Make a truth
We
table.
have to make a truth table. In our truth table, we should have I0, I1, Q0. So all your inputs, outputs, and conditions. Okay. Second thing, what should we do? Go to the first output.
First output
Coil
And
for it.
make a coil for it.
Yeah, correct. Very good. Very good. So we have taken a coil. Now you see, now you see, listen everyone. Check the true condition of Q0. And if you have more outputs, don't see other outputs or else your program will be wrong. Just see Q0 only. So Q0 is true here. When Q0 is true here, what is the status of all inputs? Tell me, what is the status of inputs here?
NO for I0 and NC
For
for
I1.
I.
Yes. See, when Q0 is true, input we have 1, Q0, I0 we have 1, I1, status of input we have 1, 0. And I told for input 1, what we have to take? And O. For input 0, what we have to take? And C. Correct, no? Here you see, connected to Q0. See here, when Q0 is 1, we have 1, 0. So for 1 you take NO, for 0 you take NC. And what is the address? I0, I1. So give it. I0, I1. Now, it is not over. Don't go to another output. Finish it first. So Q0 is true here. Check it again. Again, again, again. You see, it is on again, correct? Q0 is on again. When Q0 is on again, what is the status of inputs? Tell me.
NC for I0 and NO for I1.
NC for I0, NO for I1, because here you see we have 0, 1. So for 0 you have to take NC, for 1 you have NO. Connect to the same because it is for Q0 itself. So it should be I0, I1. Done. Check it again. Don't go for output, another output. Check it again. I shall check, check, check. It is 0. What I told, do not make program for 0. Do not make program for 0. As you include all input status, 0 will be satisfied. Don't be worried about 0. You just be worried about on, off outputs. Off will be satisfied. So this is your program. So once more, let me revise, repeat. Thank you guys for reply. So it is make a truth table, go to the first output, take a coin for it. I have taken. Check the true condition. Check the true condition. Here it is true. When it is true, input status you have to add. Input status we have 1, 0. For input 1, take ANO. For input 0, take NC. Then check again. Again it is on. When it is on again, what is the status of inputs? It's 0, 1, 0, 1. So for 0, you have to take NC. For 1, you have to take ANO. Connect to Q0 itself because it is for Q0. Do not make program for 0 of output. Clear? Suppose we have here Q1, Q2, Q3, we have many outputs. Now we have to do the same for another output. Take another coin, check all true conditions, add the status of inputs, and that is done. So take one output, finish all true conditions. Go for another output, take a coil, finish all conditions. Like that, we have to make. Before I proceed, everyone in YouTube, you have been participating. Text me, is it clear or should I repeat it once more? Text me please. Text me in group. Is it okay? Is it clear? Then I shall go for next example. You have to text in group. Clear. Okay. Fine. So I hope it is clear for all. Clear. Very good. See, if it is not clear, you don't feel hesitation to ask. See, this training is for you only, and I'm not running. I have not to finish all the things. I have to deliver the things what you can understand. So if you don't understand, you ask me. Don't feel hesitation. See, we all are friends. So there is nothing you have your professor or you have your student. Don't ask question. It's not like that. Clear? Okay. So I shall proceed. I shall proceed. Very good. You all are nice.
Sir, I have one
Next.
question.
Yeah, please ask.
Sir, in first uh, we close the IO, so I1 is already closed. Okay, our output is getting connected. The second condition, uh, I0 is already
Oh,
NO. So when I close it, it opens. Then how do if I close I1 also? How would it get connected?
so what I shall do, I shall show you the flow here. Let me run the program on screen. See this. Very first, we all will check the initial condition. Okay, look at this, please,
Okay.
everyone. Look at this, please. See, this is the main supply, this blue color. So initially, main supply will be up to this, correct? It is anode, it won't pass through. So
Yes.
here in first ladder, it is here. Now, second ladder you check. Second ladder, it will pass, correct? No? It will pass
It
through
will
this
go
because
till
it is
I1.
NC.
Yeah.
Yes. In upper ladder, you have main supply up to I0, but in lower ladder, your main supply is up to I1. Now you
Mm.
know that when NO is on, it will conduct, NC is on, it will break, correct? Fine.
Yeah.
Now I press only I0. Now only I0 is on. Let us check. So when only I0 is on, so check I0. Check I0. I0 will conduct here, correct?
Yeah.
But here what will happen?
It will
It will
open, no?
break, correct? At this,
Yeah.
yeah, it will be open. That means it will break the path, correct? So
Yeah.
in upper ladder, you see this main supply will flow. It is already connected, so it can flow and can reach you, correct? Q0 is on.
Yeah.
Lower ladder, main supply will stop here itself.
Yeah.
I0 is broken. Okay, first condition correct. Now I switch off this. Now I switch off this. So I have switched off I0. And this is the initial condition again. Now you check I1. When I press I1, it will break, correct?
Yes, sir.
This will
It
break.
breaks there and it operates
Upper
here.
ladder. But here you see I1 is on, correct? No?
Yeah.
And main supply is up to this. So this supply will proceed and will reach to Q0. Correct?
But the first
So
condition is now off, no, sir?
yeah, obviously I0 we have
As per
switched off.
truth table,
I0 is
uh,
off. Ah,
as per truth table, the
here you see.
first two steps Q0, our load should be in on condition, no?
Yeah. So you can see here, no, first condition was only I0 on. Second condition is only I1 on. Correct? No. So in second
Okay.
condition, I0 is off. Right? No? You can check this. Is it okay? Or you can tell your confusion.
No, 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 no. Fine, fine, sir. Thank you so much. Got it.
Fine. And
Yeah.
see, when we press both switches, so
Mm.
when we press both switches, it will conduct, but it will break. It will conduct, but it will break. Both upper lower paths will be broken. It will be broken here, it will be broken here, so supply won't reach to Q0. Correct?
Yes, sir. Yes, sir. Yes, sir.
Clear?
Yes,
Okay,
sir.
very good. Fine. Fine. So like this, you people ask question. If you have doubt, don't feel hesitation. It must be clear because NONC will only be used more and more. The questions are there. Let me check. explain once more background connection if it's sound connected. Nasrina Parveen Shivan's Google Meet link coordinator you check. Is this applied everywhere? Yes, we have to apply this everywhere. Uh, Further, it might get changed, but for now, you remember this that we have to apply this. NO to get on, NC to get off. Special condition we shall talk lastly. For whole 5 days, you remember NO to switch on, NC to switch off. Okay, correct.
Just a small question. So can this trick be extended for an OR gate as well? Because then the next row also becomes
In
one.
in OR gate,
Uh-huh.
let us check. I think we will have some problem because it will be applicable for interlock program. So in OR gate, I0, I1, I think it won't be because
Yeah, because as per this trick, there is each ladder created, or each branch created for one like one on of output.
yes, yes,
Whereas in OR gate it was a
yes.
single line.
Let me check. Here we should check. And when you press both switches, then also it is on. Correct, no? So in that case, what we will have to do, we will have to take three ladders. One. Okay. So you take this ladder, but see, there is no interlock in this program, right, no, sir? So if we don't have interlock, then there is no like problem of NONC. So we can make parallel connection itself. Or if you follow interlock program, what we have learned here, that will also be applicable because in that case, you will make OR gate, XOR gate, what I made just now, XOR like this. And when you press both switch, then also it should be on. In that condition, this will work. So these steps can be followed here also, but it will be lengthy because this
Yeah, and I
program
think the
has no
first two will be
interlock.
redundant, so
So
it
we
goes
can
off.
make it simple. What's that?
So it becomes redundant something.
Come again?
There is no. Is there any redundancy in these three ladder?
Redundancy is not there. No.
Not there. Okay.
Redundancy we shall learn further. No, it is not there. Okay,
Thank
right
you.
now. So for interlock, this question was good because while I explain, I must tell that this is applicable for interlock program. This is good. I shall follow this from next time. So one example, small example, first you try for these steps. Then we shall make blue green red. Blue green red we have not to make now. I give you an example. Everyone look at the screen and listen to me. We are having three inputs, I0, I1, I2, and it will have interlock also. And one output Q. That I shall do further. So we have three inputs, I0, I1, I2 and Q0 output. Conditions. When you, I shall just tell, you just make it, I won't write. Condition is, when you press any two switches among three, we have three inputs, you press any two switches, output should be on. Output should not get on by single switch or by all three switches. Got this? Once more, three inputs, I0, I1, I2, one output Q0. Press any two inputs. So how many combinations shall we have? Tell me, how many combinations we shall have to get it on?
Three.
Three.
Three
It will be
combinations.
three. So you can write down combination if you have not found I0, I1, I1, I2, I0, I2. So combinations we have I0, I1, I1, I2, I0, I2. In these three conditions, output should get on, should not get on if all three switches are pressed or single switch is pressed. So better you follow each and every step. Don't be overconfident. Follow the things. First make truth table, then go through coil, check the true condition, add it. Make it please. No need to make a big truth table. One by one you can make. I think truth table we will have I0, I1, I1, I2, I0, I2. That is it. No need to make a big truth table. For on, we shall make, that would be enough. Just take a coil and follow these true conditions and send it. Correct, Sudeep? Jatin, correct? So 2 NO, 1 NC in each ladder. In each. Yeah. Correct. Joe's correct. All are correct actually. Nanda, Raghav, all are correct. Nice. All have made it correct. So my phone internet got slow, so I'm not able to check frequently. Correct. Ankit, correct. Okay, all are correct. All are correct. Let me proceed. Look at the screen. Look at the screen. Here, again, we have to start from coil. So we take a coil Q0. It must be clear in this example, the steps. So take a coil, check the true condition. Here it is true. When it is true, status of inputs you see 1, 1, 0. So 1 is anode, 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 NC. Connect. Check it again. Here you see 0, 1, 1. So it will be NCNON. So I take here NCNON. Connect to the same output. Third one, 101. So NONCN. NONCNO. Done. So it is connected. Address, it would be all I0, these all, then all will be I1, and this will be I2, all below this. Clear? Now, once more, I shall explain that blue, green, red program example, and then you have to make that. See, I could not check all because of phone internet. It is a bit slow, but laptop internet is okay. People who have understood the program blue, green, red, try to follow, try to implement the same on that example. Yeah, all are doing good. Make blue, green, red program. All are correct actually. Some people are asking me to check, but I have seen all are correct. All are correct. Demo says it is not possible to check all, but I have seen all are correct. So once let me explain the question blue, green, red. If you were not audible, I was not audible in YouTube for some moments. So see here, in this example, we have two inputs I0, I1, I0, I1, and three outputs blue, green, red. Conditions I'm writing, listen to me, look at the screen. When you press I0, green lamp should get on. When you press I1, blue and green lamp lamps should get on, and when you press both I0 and I1 switches together, only red lamp should get on. So two inputs, three outputs, think nothing, just follow the steps. Start from truth table. Make it please, make it and send it. See, if you will apply your mind, your program will be wrong. Don't apply mind, just follow the steps. Priyanka, you see, you have interconnected blue and green. I told that we should make separately. We should take one output, finish all true condition. Then you go for another coil, another output, take all true conditions. So one by one, if you will make, there will be no problem. But if you will interconnect two outputs, or if you will start from NONC, you will get some problem. Try once more. Anmol, you make ladder also. Josh, correct. That is correct. Very good.
So one question.
Yes.
So for green, it is XOR or OR?
For green, it will be XOR. Because if you follow the steps, it will come in that one way. You don't need to think
So,
like that.
so
Just
no,
follow the steps.
uh, for XOR, for example,
Hmm.
for I naught is zero, green would not bright up, but I1 is zero, green would not bright up. But both would be one, then why not the green would bright up?
This is the condition. This is the condition of the program. You can look at the screen. When you press I0, only green. When you press I1, then also you have green, but blue also. But the condition is when we press both switches, I want only one output, red. I don't want green that time. So it depends
Okay,
on your client.
okay, sir.
Yeah. So given conditions should be satisfied. See, Jatin, what have you done? You did not follow the step. See, this I was expecting because people get overconfident. Hatake, you have also made mistake. See, this is the thing. I was sure that you will be overconfident. Raghav, it is not correct. Then Saurav, you are also not correct. Muhammad Abu, correct. Very good. Mohan, Mohan, you have taken three inputs. We have only two inputs. What, how have you taken I2? I2 we have not in our example. And then Sudeep is correct. Very good. Vishu. Vishu is correct. Nice. Ganesh, not correct. Ananda made mistake. Malya correct. Umesh, not correct. Agam, not correct. See, what are you doing? You people got overconfident. There is no name here, but it is correct. Umme Misbah is correct. Akshay Patel, correct. Very good. Anmol, your blue is not correct. Abhinav, correct.
Sir, why this is not correct, sir?
Blue, you see, when
No,
you
no, no.
press
I'm talking about my drawing, Ganesh Kumar. Actually,
Ganesh, let
yeah,
me check.
I zero. First, I have taken NO and NC, and I have given to green. So, I one is close. So when I close IO, the supply goes to the green.
See,
So
Ganesh, I
first,
forgot in which group you had sent.
WhatsApp group. Again,
Oh, WhatsApp group. We have six groups here.
Acha. Okay, no, sir. I can explain you, na.
Ah,
So
tell me.
yeah, first condition IO I1. I have taken NO for IO and IO switch and NC for I1 and green I have connected. Okay.
So what you do, Ganesh, once you sent it once more, so that I can see and you can explain it.
Okay.
Manvendra, correct. Mohan Singh, now it is correct.
Sir, I'm Anmol. Sir, in green it should be XOR. I have put XOR only using blue
In
pen.
green, it should be XOR.
Yes,
Sir,
sir.
I have sent you.
Ganesh, you see, what have you done? You have interconnected green and blue, correct? See, people
Yes, sir,
who
but
have
condition is. Mm,
I shall explain. I shall explain. Another thing, below that you have red, right? Last ladder
yeah,
red.
yeah.
Red, you have taken both NC. What does it mean? Without pressing switch, supply will reach to red. Got it? If we
Okay,
have
one
both
minute.
NC, so directly supply will reach to red. It is not the condition. Correct, no?
Okay.
And upper ladder, let me explain. You have interconnected blue and green. So what will happen when you press I0? Which output should be on? Tell me.
I0. Sorry,
When you
1 minute.
press only I0, green should be on, correct? Blue should not be on. From I0, blue should not be on.
Yes, sir. Now I0 I am pressing. In second
Uh,
ladder, I0 will get cut. So only
Second
green will
ladder,
get on.
but your both outputs are connected. No, both ladders are connected. You see. So when you press I0, you can see supply will from upper ladder supply will proceed and will reach to green and parallelly to blue also. Got this?
Okay.
Got no? From upper ladder only. Lower ladder is not in action because I0 is breaking the path. So upper ladder, I0 is on, it will proceed, will reach to green, and blue is interconnected with green. So both will get on. It is not the condition. Got this?
Okay, sir. Thank you.
Uh, yeah. So see, it is not like that you cannot take parallel outputs, but in parallel outputs, conditions should be satisfied. No. That's why I told if you don't want to think anything, simply you want to make program, then better follow the steps. Okay. So lastly, once more, let me follow the steps and again I shall give you an example. So this time I hope you will concentrate and will not make mistake again. Look at the
Okay,
screen.
sir.
Look at the screen. Everyone, look at the screen, please. Do not note down. Just look at the screen. Everyone, look at the screen. Very first, we have inputs I0, I1, and we have outputs blue, green, and red. Blue, green, and red. See this. It's very easy if you don't think anything. If you think anything, your program is wrong. So conditions let us satisfy. Just a minute. See this. When you press I0, only green should get on. That time these two should be off. Concentrate please. If you understand the concept here, your all programs will be correct. It was wrong because you did not follow the steps. I shall show you how you made mistake. When both are on, only red will be on. Now, look at the screen. I0 on, green is on. I1 on, blue and green on. Both are on, red is on. Look at the screen. Now I shall follow the steps. First step is followed. Make a truth table already made. Now, after making truth table, go to the first output. Going, you check this. Go to the first output. Mute yourself.
So what
Go to the
question?
first output. Take a please.
So both I0 and I1 when it is on, then we have only red on, no? Blue and red both.
Yes. I'm sorry, I have written here one. Sorry. I corrected. Thank you. Look at this clip. So here you made mistake. The mistake was you started from NONC and you made parallel connection. Another thing, you started from blue, suppose. So go to the first output, take a coil for it. I have taken. Check the true condition. So I'm checking. 0 we are not to make. 1 we have to make. Your problem was you were seeing, you were checking green and red also simultaneously. Don't check. Check blue
Okay.
only. So you see here, blue is on. When blue is on, check the status of inputs. Inputs we have 0, 1. Now I shall go for 0 will be NC, 1 will be anode. And believe me, I'm not thinking about another outputs. I'm just thinking about this condition one. I0, I1. Again you made mistake. You checked here, okay, I have made. You checked, okay, green is also on at the same time. So you took have. We are not making program for green now, so don't think about green. Blue you finish first. Check again. 0,
Okay.
not make program. So you, blue is finished. Correct? Blue is finished. Now you shift to green. Now I go to green. We'll take a coil for green. And believe me, I am not thinking about blue or red, just green only. So I shall take green. On input you check 1 0. So input 1 0 means NO and C. Correct? Done. Address I won't write here. You understand the I0 all will be on. Check again. Check again. Green is not over. Check again. Green is on again. When green is on again, what is the status of inputs? It is 0, 1. So I shall take separate 0, 1. Won't connect to blue. 0, 1. For the same output, so connect it. Done. Check again. Green is 0, don't make program. Green is finished. Now I shall go for red. Don't think about blue, green now, just red. Check it. 0. First let me take the coil. Red. Check. 0 don't make, 0 don't make, 1 you make. So when red is 1, input status we have 1, 1. So input status I shall add 1 and 1. Same address, all I0, all I1, you know that. That is it. If you will think more, program will be wrong. This is your first day of programming. And in first day of programming, if you make up to this, it is a big thing. So don't think anything, follow the steps. Is it clear? Anyone having question, ask me please. Any doubt, you ask me. Smritya, it's correct. Very good. Very good. Anyone having question for these steps?
No, sir.
Okay. Ashwin, you see, Ashwin, you have again interconnected blue and green. So it is not correct.
Sir, in for blue,
Huh.
I 0, 1 and blue should be glown. So I0 you have taken NC. In second
Yes.
condition, if I press the push button of IO, it gets braked, but I1 will get closed. But if IO is braked, how is supply reaches blue?
So you are talking about when we press I1, correct?
No, no, no. When we press I1, yes.
I tell you, the thing is, when you press I0, you check the conditions. You have checked. But when you go for I1, that time I0 you have to switch off, correct?
Yes.
That time I0 will off, no. So you are
Then
checking
I0
with
will
both
get
on.
cut. There will be no contact. I0 will get disconnected, na?
Okay, I shall explain this here. Look at the screen. Look at this. So this is your main supply, right? Main supply, another calculator. This is the main supply. So first, everyone will check the main supply. Initially, when you don't press switch, it will proceed and will be up to this. So first ladder you see, supply is up to I1. Second supply you check, it is up to this, and here it is up to this. Correct? And in
Yes,
this
sir.
ladder, it is up to this. Is it clear? Initial flow.
Yeah, yeah.
So supply is supply condition you understand. Now I shall go for this conditions. First condition, which input is on? Only I0. I1 is not on. Only I0. So when you press I0, all I0 addresses will be high at the same time. So here what will be the condition? It will break. Here it will conduct. As it conducts, it will and it will break. So you can see when you press I0, this ladder is not active. This ladder is active and green is on. Here it is breaking and here it is conducting. So here it will stop here itself. Is this okay? When you press I0, this is the status of signal. Is it okay?
Yes, sir. Yes, sir.
So when I go to next condition, you can see in next condition I0 should be off, correct?
Yeah,
And I1 should be on. So first
yeah.
let me off I0. So let me remove all. So this is the status of supply. This is the status of supply. So this is again in initial condition. Now I have to press only I1. So when I press I1, you see what will happen? This supply will proceed, no? This main supply will proceed, blue is on. In this I0 is off, so this will not be active. But here it is I0 off, it is active. I1 is on here, it will break. I1 is on here, what will happen? You see, main supply, it will reach to 3. Is it clear?
Yes, sir.
You have doubt here?
No, 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 no. Okay.
See, I0 is off. I0 is off, so it is already conducting because I0 is off. And I1 you have pressed. So this
Okay.
main supply is up to this. When you press I1, it will reach here. So blue green both will
Okay.
be on. And here you see it is on, but it is off. That is it. And when you press both, so it will break, it will break, it will conduct. It will conduct, it will break, it will conduct, it will conduct. So here it is breaking, here it is breaking, here it is breaking. But here it is conducting, so it is on. Clear?
Yes, sir.
Okay, okay. So I give you one last example to practice these steps. Then I shall go for next instruction. So finally, you people have to follow the steps. Don't be overconfident. Each and every step you follow, please. Important thing is you have to make program for output one by one. Do not interconnect or do not relate one output with other. One output you pick, follow all true conditions. When it is finished, then you go for another output. Okay, I'm going for next example. Ashwin, that was not correct. Okay, I have told that already. See, I told I will not be able to check all solution because people are more. I give you next example and follow the same rules. In next example, you are having 4 inputs, 4 outputs. I0, I1. I'm not making truth table. You have to do that. I shall give you enough for this because it will have more inputs, more outputs. See this. When you press I0 switch, and let me tell you, there is no push button we have been using yet. All are toggle switches, like the normal switch we use at our home. I shall explain
Okay.
this after this example. There is no push button, or else your previous example won't work for push button. I0, pump 1, and red lamp. So when you press I0, pump 1 and red lamp should get on. When you press I1, then pump 2 and red lamp should get on. When you press I2, then pump 1, 2 and green should get on. And when you press I3, all outputs should get off. All will be off. So it doesn't matter, you just follow this truth table you make and follow the steps, you will get solution. Think nothing.
Okay, sir.
Make
Okay.
this program. Everyone. And don't be in hurry, please. This program should be correct for all. Yes. Everyone, do this, please. Start from truth table. Take your time. We are not in hurry. Aditya, your question is how NC press breaks and how NO press conducts. See, NO, you see, NO contact, normally open contact. Open contact, obviously, when you press this open contact, on screen also I will show you, NO is normally not conducting because it is open. But when you press, it conducts. It is same like this, you see. It is same like this. What will happen if you press this? What will happen? It will be in contact and it will start conducting. Correct? Here also, when you press this, it will be connected, you can say. It will become NC. So initially it was NO. Now when it is pressed, it will start conducting actually. It will be connected. NC, you see. NC is already connected, means it is already conducting. It is already conducting. Circuit, you see, this is one circuit. This is one circuit, like open circuit, connected circuit. So when you press, it will be connected. It is already connected. It is like this. I shall show you. It is like this. And this is the button suppose. So here also you consider this is the button. When you press this, what will happen? It will be disconnected. No? From here, it will go down. So this circuit will be open. So here also, when it is on, NC is on, this connection will go. It will be broken. So it will become open. This NC will become open and it will break the path.
I have a doubt on your problem. Can you just clarify? So, is these
Yeah.
inputs independent? Say, like what I am meaning to say is like you have said I0 means P1 and R, and I1 means P2 and R, and sorry, I1 also mean that P1 and R should not be off on.
See, when I say I1 is on, then P2 and red should be on. Only P2
And
and red should be on. It means others should be off.
off. Okay.
Correct? So obviously P1 will be off that time. Yes. So you don't be worried. You just make a truth table, give 0101, and follow the
Ha
step. You
ha
will
ha.
get
Yeah.
solution.
My question is primarily related to that. Yeah. Okay. So which means each ladder
No
will have
problem. No problem.
all these four inputs.
Yes, yes, yes. If you ignore, then interlock lock will not be followed.
Yeah.
Yeah, so sometimes people do, like they will just make for one, they won't make for zero of input. That will be wrong.
Uh,
Make for zero and one means all inputs should be included in all four ladders. Yes, correct, correct. See, Manisha, God, you have made it correct. Very good.
Sir,
And yes,
sir, I have a doubt.
yeah,
Uh, Sir, first statement says I naught when I naught is 1, then P1 and
hmm,
R are 1. So generally we consider it as when the input is 1 0 0 0, P1 and R are 1. But then
hmm.
when like when I naught is 1, then does it mean we don't care about I1, I2, I3? Like when I naught is 1,
When
I1,
I
I
tell me.
so like when I naught is 1, P1 and R should be 1.
Hmm.
So it can be like 1, 1, 1, 1. Then also P1 and R should be 1, right, sir? Because I naught is 1, even in the case of 1, 1, 1, 1.
One. See, which one you are talking? Output one or input one?
Input 1, sir. For suppose input combination is 4 ones, sir.
See,
If the
input
input combination,
combination, I shall tell you, input combination, in first line, it is 1000, correct? When it is 1000 input, then P1 and read are on in your truth table.
yes, sir.
Check your truth table. Have you made truth table?
Yes, sir. Like they only gave about I naught, no, sir. I naught when I naught is
Hmm,
1.
no. Don't ignore another
Okay.
inputs.
Okay, sir.
In truth table, obviously, in your truth table, you will have all inputs. No, all inputs, all outputs in your truth table. So obviously, it would be I01, other will be 000. So don't ignore another inputs. All four inputs will be used in all ladders. Vishu, you are trying good. Yours is also correct, but finish the ladders. Jatin, correct. Yes, correct. Tista, correct. Ananda, correct. Now let me check another group. Sikandar, correct. Ankit, pump one is on twice, correct? Ankit, pump one is on twice. So in pump one ladder, in pump one in truth table you check, pump one is getting on twice. So parallel ladder will be there, no? And pump two is also on twice. So it will also have parallel ladder. Red is also on twice. It will also have parallel ladder. Green will have only one ladder. Check it, Ankit. 73597 35526. Your name is not here. It is your name you have written. Shahebaz. Correct. That is correct. Yours is correct.
is not I3 an useless input over here?
See, I3 is emergency off. If you press I3 anytime, all outputs will get off. Correct?
Okay.
Right? No.
Uh-huh.
Suppose pump 1 and red are on, and I have to stop everything instantly.
Mm-hmm.
So I shall just go to I3, will press it. All will be
Mm-hmm.
off.
Got it, got it.
Shubhranshu, your green is not correct. I think you have 1, 2, 3, 4. I think you made truth table like that. Instead of Q3, you have to take green, and like that you check. Priyanka, correct. Mohan, Mohan Singh, correct, correct. Anmol, correct. Jose, correct. Raghav, correct. Muhammad Abu, the picture is not clear, but it is correct because it was not downloaded. Now it has come, it is clear. Correct. Locus, it is correct. Agam, it is correct. Harit, correct. Nitish, Nitish, correct. This time you are doing good, you people. Ume Mishwa, correct. Looking at ladder diagram, how can we get to know that which input is high? Oh, we can check that. I shall show you on screen. Akshay Patil, correct. See, all have made correct. Saurabh, you are correct. Gayatri, correct. Very good. All have made it correct this time. Tanis, correct. Fine, fine. So all have made it correct. There is a question, how can we check whether program is working correct or not? How can we check output is on or not on notebook? I had shown that in previous example also. It is pump 1, 1, 0. Then 0, 0, 1, 0. See, you can check NC is already conducting everywhere. NC will be conducting already. So when you press I0, you have to check NO. Where is NO? Here it is. If it is on and other are NC, then obviously when it is on, supply will reach to pump 1 and we can understand, okay, it is on. When it is off and suppose this is on, I2 is on, you can see in this ladder, all are NC, all are already conducting and this is also conducting now. So this will be on. So like that you will have to check on your notebook. So we have 20 minutes. Before I go for next instruction, I request you people to ask questions. Clarify, I shall clarify all your doubts. Don't keep any confusion with you. Tell me if you have any kind of issue like confusion, any silly confusion also, then also you ask. Please ask the questions. B. Priyanka, it is correct. Ask question, compulsory. This is compulsory. You have to ask question. Tell me. Atul, it is correct. Smritya, it is correct. Very good. Ganesh,
Yes, sir.
again, yeah, again you see, what have you done? How many coils you have taken? How many coils
O-
do you have?
Output we
See,
should not. We should have take only one.
one, and see why it is done, because you started from NONC, correct?
Yeah.
Yeah, that's why you started with NONC and you made combination of outputs. So you should start from output. Take one output and give the combination of inputs. You can see others' solution how they made.
Okay. Okay. Okay.
Maulya Mahesh, correct. Can you repeat simple truth table of input and output? So the steps you want to know, Abhishek, correct? I shall repeat it, no problem. What if both I0 and I1 are on and other two are off, for example? See, Natish, in this example, pump 1, pump 2 example, you can see on the screen, you can look at the screen, you can see your output will be on if any single input is on, correct? If any single input is on, you can see either I0 is on, I1 is on, or I2 is on, single input. Then only your output will be on. It means, obviously, due to interlock, because of interlock, it should not get on, nothing should get on if you press more than one switch, correct? So when you press I0, I1 both at the same time, or any two or more inputs at the same time, in this program, output won't be on, and that is already satisfied because you have many NC objects in your program. Natish,
Yes, sir. Understood, sir.
ah, does NONC work on principle of push button? Push button, see, push button has not come in picture yet. I shall come to the push button now. But you are correct. You have seen green push button is NO type and red push button is NC type. The same thing we have in NONC program NONC also, but this is virtual. Program NONC is virtual. But if you say that push button we have not used. But you are correct. It works like that only. NONC works like those green and red push button, physical. Abhishek, do you want me to repeat the truth table of inputs or outputs? Okay. Uh, does this truth table principle work for storing the output in memory instead of displaying program? No, 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 no. Storage has not yet come. We have not stored any signal yet, and that will not be applicable. This rule, truth table program steps won't be applicable for that. I shall explain it once more. No problem. I shall repeat the steps once more. Let me take all questions. One person is I am Satan. Yours is correct actually. Satan or Satan because emoji is of Satan. So Shubhranshu, it is correct. Let me take all questions. I shall reply all. How to solve this problem? Which problem? Aditya V. Which problem? How to solve this problem? The questions say P1 and R should be on for I0 and it is quoting them from okay the question the table that P1 and R are on simultaneously for only one combination. Mm, no. In see pump 1 and raid, pump 1 is getting on twice. So pump 1 has two conditions to get it on. That's why we have parallel connection in that. Raid is also getting on twice. So it has also two conditions to get it on. That's why we have parallel connection. You see green. Green is getting on once only. So green is having only one ladder. It has no parallel connection. Okay, Manjit, yours is correct. But your name, you see what you have written. Okay, nice. So once I need to repeat the steps. Listen, lastly, then I shall go for next instruction, you can say. So when you have simple examples where you have just inputs, outputs, on and off condition, there you don't have complication, not complicated example, just on and off. Then you have to follow few steps and you have see I shall tell you there is no rule of logic, developing logic, making program. My method can be different, your method can be different, another's method can be different. So what I have told you is not a rule, but I have suggested you one easy way to make program, and you have seen if you thought a lot, your program was wrong. But if you have followed the steps blindly, you got the solution, correct? Correct solution. So I shall again tell you this is not a rule, but this is one of the methods you can follow to make your program. So the method I told you, first you should make a truth table. After making truth table, you should go to the first output. Make a coil, and you have seen if you started from NONC, you made mistake. You took parallel connection or series connection of output. That is correct. That is wrong. So make a truth table, go to the first output, take a coil for it, check true condition of that output and add the status of all inputs you have used, correct? Add all input status, and you have not to ignore off inputs. Off inputs will also be there. On input, off input, both will be there. So 1 0 0 0 you have taken like that. So check the true condition of output and add the status of all inputs you have used. Input 1 will be NO, input 0 will be NC. Do not make program for output zero of output. Do not make program for zero of output. That was the thing. How to solve this problem? One, we should use error, and zero, we should use NC. Yeah, for input 1 we should use NO, and for input 0 we should use NC. Correct. Who is asking for attendance? It is not over. We won't give you attendance. I think you did not attend the class then. You directly came for attendance. Class is not over yet. It's 2:50. Class will go up to 4 o'clock. Listen now. Sahib, this is Delta PLC, correct? This is Delta PLC, Sahib. We shall learn Mitsubishi programming. It has the same programming. Delta has the same programming. What we shall use for Mitsubishi, I shall explain that. So Delta I shall try to simulate here. Truth table for which, for last example you want? Truth table? Okay, I shall make. See, you people don't be impatient, just keep patience and see. I want everyone to learn the things. I don't want to skip some people. So I shall take all questions and will clarify the doubts. Then I shall go for next one. So for the table, you can see 1, 2, 3, 4, 5, 6, 7, 8. And we have 1 issue, 2 condition, 3 and 4. So it is, look at this, I0, I1, I2, I3, then pump 1, pump 2, red and green. So when I0 is on, other inputs are off, pump 1 and red will be on, correct? When I1 is on, then pump 2 and red will be on. When I2 is on, then pump 1, pump 2 and green will be on. And when you press I3, all will be off, like that. And did I tell you to start the program? You just go to pump 1, you should take a coil like this. And then you check the true condition. Here it is true. Only pump 1 you see. Here it is true. When it is true, you can check. Inputs you have 1, 0, 0, 0. So obviously it would be 1, 0, 0 and 0 connected. Then check it again. 0 you don't make, 1. So pump 1 is on again. When it is on again, what is the status of input? 0, 0. So here 0 NC, 0, 1 NO, 0 NC, connect for pump 1, and it is done. So like that, you have to take another coil, all true condition, another coil, all true condition. It will be done. Correct. Yes. Fine. So I hope the things are clear. Yes. Fine. So this session also I shall extend for 15 minutes because I want today's part to be finished. Although we did not start software. Tomorrow, everyone be ready with software in your laptop. In first session only. In first session, we shall start with software practice. So tomorrow it would be more practice. Theory will also be there, programming will be there, but we shall practice. So today, Gayatri has shared a video to install the software. You can go in the group and she will share again. You install software in your laptop or computer. It will not be installed in phone. So for 15 minutes, look at the screen, please. Yeah, correct, Manisha. Correct, Devasis. Okay, so look at the screen and we shall go for next thing. This program was the first program. And let me tell you, if you don't follow truth table today, then we could not make these many examples. If you go through random thinking, we could not make last example today. So because of truth table, we have made all examples today itself. Now you come to this example, look at the screen, and now again it is important, although everything is important, but you need to understand it. If you don't understand next topics, you won't understand. So this is important. In this program, we have one switch, one motor. When we press the switch, motor is on. When we switch off the switch, motor is off. Let me tell you, all our examples we have made yet. In all examples, we will do the software part tomorrow. After session, you can do this. Now look at the screen. In all our examples, we have used toggle switches. All switches I0, I1, I2, I3, these are toggle. Toggle switch has property, it holds its position when you operate it. Normal switches that you use at your home, in your college also, to get the fan on, to get the lamp on, or other things. These are toggle switches. Toggle switch will hold its position. Holding its position means, you have seen, no? When you have to get the fan on, you press the switch. As you press the switch, fan is on. You leave the switch. As you remove your hand from the switch, what happens? Switch is continue on. Correct? Switch will hold its position. That is toggle switch. So when switch will hold its position will be toggle switch. And in all our examples, we have used toggle only. So here you see, if we have a toggle switch and we press it, we make it on, it will be continue on. If it is continue on, motor will run continuously. If you make it off, what will happen? I0 off, Q0 off. Now, in industry, most of time, you have to use push buttons for on and off. In industry, maximum time, you have to use push buttons. at green color and red color. So leave green color and red color. You consider only green color. Red color push button you forget. Don't think about that. So in industry, most of time you have to use push button, and push button has property, it will restore its position. How you see? Push button has spring system inside it. Spring system. It has one button also. What you press, from which you press this. So what happens when you press this? It will be connected, correct? It will be connected. But you are not going to press this for long, correct? You will leave the push button. As you leave push button, due to spring system, you see it will be open again. Means your push button will be off. Got it? So if we have a push button, I0 is a push button. Suppose I0 is a push button here. You see this. Now I0 is a push button. How will it work? How will this ladder function? See this. As you press the push button, I0 will be on. Motor will run. But you are not going to press the push button for long, you leave it. As you leave push button, what will happen? This is open. Due to spring system, it is open. So as you leave the push button is off. As push button is off, what will happen? I0 is off. As I0 is off, what will happen? Motor will be off. Motor is off. So this ladder will not function for push button. Be very clear. Is it clear? Tell me. Tell me. For push button, this ladder won't function. Is it clear?
Yes, sir. Yes, sir.
Yeah. So in all our examples, if we have push button, it is not going to function. It is not going to work. Correct? So some modifications will be required. Some modifications will be required. What would be the modification? The modification is called latch. L-A-T-C-H. L-A-T-C-H. Latch. If you want your output coil or the coil you say, if you want this coil to be continue on, you need to latch this coil. I shall explain it, don't worry. So now our practical requirement you see. The practical requirement is we have a push button I0. We have a motor. Push button is connected to I0 of PLC and motor is connected to Q0 of PLC. When we press the push button, motor should start running at the press only. But when you leave the push button is off, but no problem. Motor should keep running. Motor should keep running. This is the requirement. For that, we can make our program in the same way. Toggle program we have made. After making toggle program, we have to latch the coil. We have to latch the coil. How do we make latch? See, if I make a parallel connection here, and I give here I1 suppose, I1. If I make a parallel connection and I give here I1, this will be called a parallel. But instead of this address, if I give it coil address, see this, if I give in parallel, if I give this coil address, whatever address we have in coil, if I give in parallel, now it will become a latch. I want to clarify something here. This is also parallel connection, but this parallel connection will be called latch. Why? Because this parallel contact is having coil address, same address of the coil. Now it is latch. But instead of Q0, we have another address. Suppose we have Q1 here. If we have Q1 in parallel, That will be parallel connection, not latch connection. Latch connection will have coil address, same coil address. Then it will be latch. Is this clear? The difference between parallel and latch? Is it clear?
Yes, sir.
So latch, when we shall call it latch, when parallel will have your coil address. When parallel contact will have coil address, it will be latch. Now I shall show you how will it work. Just a minute. Now I shall show you how will it work. How will it hold the output status? Concentrate please. This is the main supply. So main supply will be up to this and will be up to this. Clear? The main supply will be up to this contact, will be up to parallel contact also, latch contact also. Now nothing is on. Be very clear. Nothing is on. Nothing is on. Everything is off. Everything's off. Now I go to this push button. Now I go to the machine. This is virtual part. This is your machine. We go to the machine and we press the push button. What will happen? I0 will be on, correct? As I press the push button, I0 will be on. As I0 is on, you can see this. This will be active, will be high. Now it is conducting, so this main supply will proceed. What will happen? Q0 is on. Is it clear up to this? Is it clear up to this?
Yes, sir.
So when we press the push button, immediately upper ladder I0 is high, upper path will be active and supply will reach to Q0. Now this Q0 is on. As this Q0 is on, all Q0 addresses in your program will get high at the same time. So as this is on, here also Q0, this will also get on. So initially it was not on. When Q0 got on, then this contact was on. Now this parallel path will also be active and will reach to Q0. So now you have two paths. One from here and another from here. You have two paths to get the Q0 on. Now I go and will leave the push button. Now I leave the push button. As I leave this push button, I0 is off. As I0 is off, you see I0 is off. What will happen? This path is not active, you see. This path is not active. No problem. This path is active, no problem. Still we are getting supply through this parallel path. Correct? Still we are getting supply through this parallel path. Once you tell me, is it clear? Don't worry, I shall repeat it. I know in one attempt it is not easy to understand. But up to this,
Yes, sir. Got it.
is it a bit clear?
Yes, sir. Yes, sir.
Okay. Once more I shall explain it. Concentrate. This time your doubts will be clear. First of all, you should see that nothing is on. You can see I0 is not on, Q0 is not on, nothing is on. See this. Q0 is off, this Q0 is also off, this Q0 is also off. Initially, main supply is up to this, is up to this. So both contacts are having main supply, but not passing through this because everything is off. Now, I press this push button. As I press push button, I0 gets high. As I0 gets high, what happens? Main supply will proceed and will reach to Q0. It has reached. As this Q0 is high, we have the same address here. So this address will also get high. As this coil address is high, we have the same address. This will also get high. So now this is also high. So you can see main supply reaches to Q0 by two paths, upper path from push button and lower path from latch. So you have two paths to get Q0 on. Initially it was on by I0, now it has latch path also. So now we press, now we leave push button. Now we leave push button. As we leave push button, I0 is off. As I0 is off, this path is not active. This path is not active, upper path. But no problem, Q0 won't be off. Why? Because this parallel path is still active. Parallel path we did not break. If we break this path, then only this Q0 will be off. Parallel latch will make your output continue on. This latch is making the output continue on. Text me in group also. Is it clear? If it is not clear, I shall explain once more.
Clear, sir.
Okay. YouTube participants, is it clear? Latch means how does it make output on? Continue. Is it clear? YouTube participants. See, we need push button because if you use toggle switch, you will have to keep continue on. Keeping continue on means supply will pass through the switch continuously for a long time. Might be your machine will be on for 8 hours, 20 hours or 24 hours. Continuously supply, you don't need to pass through the wire. Virtually you can store that. Virtually you can get it continue on. So toggle will not be used. Push buttons will be used there. Push button plus latch work on NONC. As NONC. Shahib, you are talking about physical connection, I think. In software, okay. First, you tell me, is it clear? This virtual latch is clear or not? If it is clear, I shall go for next. Okay, I proceed. I shall proceed. Fine. So it is not over. See, it is not over because once this output is on, is continue on. Tell me, can you switch off this from this circuit? From program, can you off the Q0? Tell me.
No, sir.
Can you switch off Q0 in this ladder?
No, sir, it cannot be.
No. Yeah. Because to switch off, we must have some NC, correct? We must have some NC to break this path. So we must have one NC in this path, anywhere. You can have here also, here also, anywhere. So we must have one NC to break this path. So here I put, and we need to give one more push button. That's why you have seen you will have two push buttons, one for on and one for off, correct? So one NC will be required. So let me operate this. When I1 is pressed, NC will break the path. As NC will break the path, Q0 will be off. So this will also be off. Finally, everything will be off. So you need to remember a few things here. I shall tell you. The things are, if you want coil continue on, if you want the coil continue on, latch this. Clear? If you want coil continue on, latch that. You must have one NC to break that latch. It is more important that you must have one NC to break that latch. So first thing is, if you want the coil continue on, make a latch. More important is, if you have a latch, you must have one NC to break that latch. If you don't have NC, it won't be off. It won't be off. Okay. One last thing, 5 minutes only. One last thing. So
Yes, sir,
this
sir,
is
no
clear
problem.
that ah, if we want output continue on, we need to latch the output. But if we have a latch, it must be one NC to break that latch. It is compulsory, or else your output will not get off. Now the thing is, you will have a doubt that if we have a push button, do we need to make program again for all previous examples? We can make some modification and it will be done. For example, see this. For example, I take first ladder, pump 1, pump 2 program, first ladder, P1. For example, it was NO, NC, NC, and so I0, I1, I2, and I3. In parallel also we have one ladder. So it was NC, NC, NO, NC, and the same address. Same address. This is your pump 1 ladder you have in your notebook. Look at the screen. This ladder will work if we have all 4 inputs toggled, correct? If we have toggle switches, then only this ladder will work. But now we have all these push buttons. Now we have all these push buttons. So if we have a push button, obviously we will have to make a latch of pump 1, correct? We will have to make a latch of pump 1. So simply
Yes,
what we
sir.
think, we make latch like this. But there is an issue here. If we make a latch like this, we need one NC, correct? We need one NC. Either here or here, we need one NC. Everyone, I hope everyone has been listening carefully. Tell me, look at the screen and tell me. If we make a latch like this, we need one NC that is shown. Without NC, it won't work. If we take one NC here, what would be the address of this NC? Tell me. Tell me, anyone.
I3.
Text me
I3.
in I3. Other people, text me in WhatsApp group. What should be the address of this NC?
It will be P1, sir.
P1 cannot break itself, correct? P1, if you will put P1 here, then P1 will not get on, because as it is on, it will break itself. Suicide, P1 will do suicide. P1 will not be applicable. Participants from YouTube, you text me, what should be the address to break that latch? I4. Okay. Other guys? So here you see we have some confusion, right? And we have not only one ladder, but we have 4 outputs. So when we will take four
No,
latches,
just
we
we
will
can
have,
shift this I3 switch there, no, sir, not in the main ladder, and we put the I3 switch after the
but you
latch.
see, pump one, correct. But you see, sir, pump one is not getting off only by I3. Pump 1 should get off when I2 is on. Pump 1 should get off when I1 is off. Correct? No? 1 is on actually. So pump 1 has three conditions to get off. So you can't put all addresses, or you can't put all, you can't shift all NC outside. Correct? So this is the issue, that pump 1 is not getting off by I3 only, but it has another condition. Like that, if you will go for pump 2, it has another condition, red has another condition, green has another condition to get off. So every time when you latch, you will get this issue that you will get confused to give address of NC. So I suggest one thing, I4 we cannot use. Why? Because I4, if you take one more push button, you will have to connect to PLC. So client won't give you new push button to break latch. You have to take NC address from your program itself. Be very clear. Your NC address must be from your program. Now you see, do one simple thing. One more simple thing, let me tell you. The simple thing you can do, remember, to convert, listen carefully, to convert toggle program into push button program, to convert toggle program, this is toggle program, convert toggle program into push button program, take latch of output, here output is P1, take latch of output below each anode contact. Once more, listen carefully. It is the simplest way you can follow. To convert toggle program, and you know toggle program you can make using truth table. After making toggle program, to convert it into push button program, take latch of output below each anode contact. Let me do that. For this ladder, for this network, output is P1. So take P1 latch below each anode contact. Let us find out anode. Here it is anode. So take a latch below anode P1, and you can see this is your latch path, and already three NC contacts are available for this latch. But in this network, you have one more anode. So here also you need to give a latch. So take latch of output below each anode contact. And here also you see 1, 2, 3, 3 NC contacts are already available. You don't need to put it from outside. So this thing you can follow. Take latch of output below each anode contact like this. So one last task for you, it will take 2 minutes. You already have made this program, pump 1, pump 2, red and green ladder, you have already made. In the existing program, no need to write it again. In the existing program, take latch of output below each anode contact. So convert that into push button program. No need to make it again. You already have made pump 1, pump 2, red and green program. Take latch of output below each anode contact. So convert that program into push button program and send me in group. Send me in group. So modify your program, please. For push button, you modify your existing program and send it in group. Make it fast. We shall bind up after that. The pump 1, pump 2 program means all four networks you latch, make latch. In four networks, you make latch. In existing program, pump 1, pump 2, green and red, you make latch.
Hello, sir.
Hmm.
I have one
Tell.
question.
Yes.
Uh, in the if we are converting it to push button program, then these normally connected switches will also be push buttons, no?
I didn't understand.
Or
Once
they
more,
will be
please.
toggle switches.
No, no, no. See, if
See,
you
uh,
use
when they are
latch, then generally it is push button. So all your switches will be considered push button. But let me tell you one more thing. Suppose you have toggle program, like you have toggle switches. You have toggle switches. You don't have push button. But the requirement is when you press the toggle switch on, motor should run. And when you get the toggle switch off, then also motor should run. Did you understand the condition? Got this condition?
yes, yes, sir.
Ah. So the condition is we have a toggle switch and we have a motor. When we press the toggle switch on, motor should be on. And when the toggle switch is off, then also motor should be continue on. In that case also you need latch. Correct? No? In that case also you need latch. So it doesn't matter whether it is toggle switch or push button. If the condition is that switch is off, then also output should be on, latch will be required. But generally, whenever we have push button, latch is compulsory. For push button, latch is compulsory. Is it clear? Manisha, you have not to make latch in blue, green, red because in blue, green, red we have some condition we shall discuss tomorrow. You have to make latch in pump 1, pump 2, red and green program. Correct. Others? Correct. Very nice. Nice. So it is clear to all. It is clear to all. So finally, in 2 minutes, let me revise the things and we'll wind up. Actually, now I feel that why did I reduce the time? Because it was proposed that we can have session up to 4 o'clock, but I told no, it is online. Let it be up to 3 o'clock. But I think it was good if it was for up to 4 o'clock. But no problem. So finally, let me revise the things. Today we had to finish those theoretical things also that I did not do. Tomorrow morning, please remind me. Huh? As I start the session, you remind me PLC block diagram, then layer of automation, all these things I shall clear. So today we learned that if we have to make program, simple program through table, rules or steps we can follow. We have also understood manual operation, relay logic controller, difference between, or not difference, limitation of microcontroller, why we use PLC in industry. Then we learned NO NC coil, basic instruction, and just now we have finished latch. In latch, important thing to remember, if you want the coil continue on, latch it. If you have a latch, it must be one NC to break that latch. Tomorrow we shall have more interesting and big programs. Tomorrow early morning, first session, we shall try to make all examples what we did today in Codesys software. And tomorrow after lunch, we shall go through higher instructions. Higher means it will be higher than NONC coil. Mostly, I think timer and flag. Timer and flag, because timer is the main instruction in automation. Timer will make the machine automatic. So tomorrow you can say 80% programming you will learn. So tomorrow I shall give you another steps or tricks to make program for machines. I hope today you have learned something, and obviously because we have a very big number of participants, so some issues will be there, I'm sure. If you have any issue, you convey, we shall try to sort it out. And it totally depends on you. If you are interested, keep patience, ask question, we will clarify. And I promise again that I shall make you PLC programmer. And last day, you will be able to talk about all systems of automation, industrial automation, among a group of people. So be attentive. Thank you for today's cooperation. You people are
Thank you,
very
sir.
good.
Thank you so much.
Yeah. Thank you very much. We shall wind up. See you tomorrow. I hope all will join tomorrow again.
Yes,
If
sir.
you want to
Thank you
know,
so
Thank you.
much, sir.
anytime.
Thank you,
Thanks.
sir.
Thank you.
Have a
Bye.
good day, sir.
Thank you
Bye,
for the
Michelle.
session, sir.
Yeah, yeah. Thank you. Thank you.